Hello class, well it's July 11th and pretty crazy weather as I record this video. The rain's coming down and the thunder is just booming outside. But anyway, you need not worry about that because this week is about statistics. Some people call them sadistics, but anyway, they're statistics. And statistics is a great topic to have. Actually, the topics for the next 2 weeks are about data analysis. So this week's topic is quantitative data analysis. Statistics is a quantitative data analysis tool that you can use to analyze your data when you have a quantitative study. And then next week we'll talk about qualitative data analysis. So really we're talking about data analysis now. It's that part of the research process when you have completed collecting all the data, whether it's qualitative or quantitative, but you've completed it, all your participants are done for your study, and now you need to do something with all that data that you've received. So for the activities this week, you'll read chapters 17 and 18 on descriptive statistics and inferential statistics, and then take the quizzes on those chapters as well. This is one of those rare weeks in the semester that there is no discussion board, so there won't be any discussion for this week. But instead, you have your literature review due. And so you're going to take the feedback that you received on your preliminary literature review and update it. And so make sure that you add the sources of information that you should add. A good lit review should have 15 or more sources of information, as you see there for one of the requirements. It should be focused toward your planned research study that you've been working on in your proposal. Everything should come together. This is the part of the semester where everything comes together with all these assignments that you've been submitting. The studies should be categorized logically according to results, types of studies, focus of studies, or another logical factor. A lot of people have done focus of studies, and I think that's a good way to go. You can focus on different aspects of what your research is about and say these are different studies that looked at factors related to this, and that relates to your study. And then these are other studies that have looked at the factors like this. That's usually the better way to go, especially for this class. And then writing flows logically and systematically, and you'll include things like an introduction, body, and summary into your literature review. So what I'm going to be looking for this assignment is that methods, results, and findings from each reference study are adequately presented. So don't just say these guys found this. Instead, maybe have another sentence or two about the study and what are maybe some of the results. What were the methods that they followed to do it? Maybe even if there's a flaw in the study or a way that you think the study isn't very good, maybe talk about that. We need to be critical as researchers. The next one is the literature review. Includes the required structure, introduction, body, and summary. So the summary and the introduction are kind of it's not your words, it's you restating what is in that literature review. It's you kind of retelling overall, here are the general findings. And remember, with a lit review and with academic writing, you don't put I, me, or we you don't refer to yourself in the document, so just beware of that. It flows well. I'm looking for a good flow with transitional and organizing sentences and paragraphs. For instance, you might have a list of studies that are about cognitive dissonance, for instance. And you might say, many researchers have studied cognitive dissonance as a factor in this problem. And that's a good transitional sentence to kind of say, okay, now we're going to talk about cognitive dissonance and studies that relate to that. Let's see, it organizes reference studies logically, as I mentioned, proper APA formatting for the document, for in-text citations. There are 15 or more sources cited and referenced, and then proper APA formatting is used for the reference list and spelling grammatical errors. Those all add up for the final score for the lit review, which again is due this Saturday. So just what you really need to do for this is just to take your previous literature review. If you haven't already, make some suggested changes that I gave you from that. Then go ahead and, if you haven't already, add in the extra sources that you found, and maybe you can even fit them into the part of the organization of the literature review that you already have, which is nice, right? You can just throw extra sources in there, talk about the studies a little bit more, remember, tell about the methods, results, and findings from each study, and add those in. And then you'll have your final literature review. And hopefully you have been reading those articles, continuing to read articles within your area of interest as you go along. That will make things a lot easier for this week. Also be aware that we are kind of wrapping things up. We only have a few more weeks after this one, 2 more weeks. So next week is your final proposal. This is your final research proposal due next week. You don't actually, remember, you don't actually have to do the research study that you are proposing, but you will have to submit this final proposal with a cover page, an abstract, things like the introduction, the review of related literature, that's what you're writing this week. All the things that you've done before, and then also the data analysis methods, your planned data analysis methods. So how will you analyze the data? How do you propose to do that? You don't actually have to analyze the data or collect any data, but you can propose a method for doing so for what type of study you're doing. So really what you're doing is compiling everything that you've submitted so far into a nice document with all these elements as ordered as is mentioned here, but the parts that are bolded are the new ones, the cover page, the abstract, and data analysis methods. And then after that, there's just a couple of assignments due the next week as well, evaluating a research article and a letter of consent. And those will be due on the last week of the class. So we're really winding down with the class in a lot of ways. So that's what's due this week. So that's what you're going to do this week, but I did want to talk a little bit more about statistics. Descriptive statistics are statistics that you can use to describe what a certain population is like. Let's say you sent out a survey and you have a certain question on that survey, and on the question, let's say that 60% of people who were in group A answered that question strongly agree, but let's say that only 20% of group B answered that question strongly agree. So that would be a descriptive statistic. It describes how many people responded in a certain way, and it gives you percentages. It doesn't really do much more math than kind of just tallying up the numbers, figuring out what the percentages are, and making some descriptions. Although you can do more than that. I mean, there's more to it than that, as you'll read. And then in inferential statistics, you're thinking about population versus sample. So every research study only has a sample of the population. You can't really, most research studies anyway, you can't really get the whole population to respond to your instrument. And so inferential statistics allows you to say, how likely is the full population going to be like this sample in my research study? How likely is the full population going to be answering the same kinds of questions the same way? And so if you have a good statistic that you've run, and you say, well, I was only able to get 100 people, even though the population total was about 1,000, and the 100 people responded in this way, but statistically, I use some inferential statistics, so based on those inferential statistics, I can say that the population is likely a lot like this small sample that I received in the study. So that's what inferential statistics is about. And I do want to share some of these other videos, some of an older video that I've recorded about statistics as well, so I'll go ahead and put that in here now. So let's say you have a research study here. You're comparing one group of people versus another group. And these are the two groups. So let's say this group has, they take a test, let's say, and group one has received a different type of treatment. Maybe they've received special counseling, and then they take a test, and they have an average score of 50 on that test. And over here on the right, we have group 2, and they have an average score of 45. And so statistics can help us to know whether the special treatment that was received in this group is likely to be something that will work in other situations as well. So group 1 received this special type of counseling, then they took a test, and they got a higher score, which was good. That's what you want to have happen. Group 2 did not receive any such special counseling, and therefore they only have 45, or at least that's what we think, and that group only has 45. So based on this, we can say, well, it looks like we should do that counseling for everybody, right? But you don't really know for sure, because maybe just the first group is a better group. Maybe they came into the situation as a better group than the second group. Maybe there are certain characteristics about that group that we didn't really take into account. So that's why we do statistics, is we try to figure out exactly why. We try to figure out what's the probability that group 1 would always score this way. And then if we can figure out that probability, we can say, okay, now we know for sure that there is a statistically significant difference between the groups. And meaning that if we implement this special counseling program to everybody, most likely whatever groups we implement it to will score better than groups that don't receive that type of counseling. So that's something to think about as well. It's just the idea of statistics helping us to figure out how things go. But of course you have to have numeric information. It has to be a part of a quantitative study in order for you to be able to determine statistical significance between the types of groups. So an inferential statistics will tell us whether or not these samples would relate to the entire population at large, like I mentioned. Another example is, let's say you have a group of students and they keep averaging about 50 points. Let's say it's students in a classroom, and hold on, and they week after week they take a reading test score and they get 50 points, an average of 50 points on that reading test score. So let's say there are 25 students in the class, they keep getting 50 points on a test score. And it's like a research study that we're actually running. And then you implement something special. So I'll use another shape for that, maybe a heart. Maybe a heart will implement that. Okay. So then we have this heart here, and we implement something special every week. So we have a bunch of hearts. Oops, I need to copy the heart. And then what we see happening from that is that once that special implementation, maybe it's a new reading curriculum, has been implemented, we see that students gain a higher score. Maybe it's 60 is their average score among 25 students. So you might look at this and you might say, well, great. I mean, it looks like the heart implementation that we create is working. But again, a statistical expert would say, well, you don't really know, because you don't know what the probability was that students may have gotten this from just improving over time. People get older, for instance, and as we get older, students tend to get a little smarter, more intelligent. There's a lot that can be done with this information. So that's one thing to be aware of, is that statistical significance allows us to know whether the changes that happen are really changes or are likely to happen, or they are not likely to happen based on statistical methods. And if we do find a statistically significant difference between 50 and 60 here, and these ones, then we can say, well, it's likely that whatever we implemented, the hearts, whatever we implemented was the effect of that. That's what affected it and made it happen. And if that is not statistically significant, we can say, well, then the 60s are based on just other things maybe. Students got a little bit smarter over time, but we can't really necessarily say it was because of what we implemented. So that's sort of statistics on the basic level. What you need to know is kind of what I'm presenting here, and of course the things that you'll read in the book and take a quiz on this week. But I don't expect you to be an expert on statistical methods after just a week on statistics in a class. In fact, in my doctorate program, I had to take many different semesters, I think 3 or 4 semesters of classes on statistical methods to understand them for research purposes. Now, I did want to introduce you to a few statistical methods, or at least SPSS, which is something that is also mentioned in your textbook as you looked at inferential statistics and data. So SPSS has a nice data editor. You can enter data in here and you can actually crunch the statistics without having to do all the math necessarily. It is good to understand as much as you can about statistics before doing anything like this. And but I'll just show you a couple of the more common methods of calculating things. So for instance, I can look at compare means here and analyze this set of data on sex, age, benefits, honest, nice, virtuous. There's a whole bunch of different information on each person. And I can just do this independent samples t-test. Now again, a t-test is a test to determine differences between two groups. It's generally just for two groups and to tell what the difference is between them. So I have this grouping variable down here called sex. Basically that means gender, right? And it's 1 or 2. And then I want to see if there are any differences on these variables. If there's maybe one of the genders is wiser than the other, or better, or good, more good. So then I can just run this nice little test, and it provides me with the number of people in each one, and it also provides me with a mean for each one. So it looks like, for good anyway, gender 1, which I think is male, is 5.28, while gender 2 is 5.29. That's a different mean there. And then for males, 5.33 and 5.61 on Ys. And it tells me these measures of variance too, standard deviation, for instance, and standard error mean. Down here, though, it'll test significance. It tells me a value, a t-value here, and degrees of freedom, and it gives me a significance value. Now I'm looking for a significance probability. Most statistics are looking for a 95% probability that something is different, and so that would be 0.05 or less, or less than 0.05 actually is what we're looking for, because we're looking for greater than 95% probability. In this case, I'm not getting that, right? There is no significant difference, because that number there, the 0.482 under sig, significance, is higher than a 0.05, not lower. So that is not significance. In other words, even though this mean says that in general women are more wise than men in this case, or in this population, or in this sample anyway, even though that's what it says, the mean is a little bit higher, we can't rule out other things that make that so. And so we can say that with pretty good surety that no, there are no differences among genders in this case, on wisdom or goodness, as the case is. So statistics can be run very easily using something like SPSS statistics, and help us to do it a lot more quickly and understand it a lot more quickly. Another possible test for comparing means is ANOVA, analysis of variance. And again, that's just another way of finding out things. So I'm going to enter in the factor sex and then enter in good and wise again, so we see how they look. So dependent list and factors, and we can hit OK on this one, and it gives us again another significance item right here, and it gives us a 0.454, which means that's higher again than 0.05. That means it's not significant difference between males and females. Same answer as before, but just a different way of finding it. We're running ANOVA now. One big difference between t-tests and ANOVA is that t-tests usually are meant to only take differences between two groups. And ANOVA, you can take more than that groups. You can take multiple groups, or two. So that just shows you a few tests in SPSS for this week. Okay, so that's just a little intro to statistics for you as you get started with this week. Have a great week, and I'll be grading your assignments very soon in the next few days. Have a good week.